Hi guys, this is Ajin Abraham. Welcome to the Exploit Research and Development series. So today we will look into exploit development with Mona. So what is Mona? Mona is a plugin for Immunity Debugger or WinDebug, and it is developed by Peter, also known as Corland Scoder of Corland team. So Mona is basically a Python script that will simplify the efforts of an exploit developer into many folds. As far as I think, this tool is created to make exploit development so noobish. So why I tell this? Because you don't have to spend days or hours, or you don't have to do any hard work for just developing a basic exploit. Mona will do almost everything for you. So it can automate the stuff that make me feel like exploit development is made noobish by Mona. Just joking. And these are the set of commands which are supported by Mona. Okay, so we will look into some of these commands, and these are some of the global options that help us to apply some filter on our commands. So these are some of the filters. We will be going through some of the filters. We cannot obviously cover all the commands and the filters, everything, but we will just go with the important ones. Now we have to install and configure Mona. So just Google for mona.py and download it and copy it into the PyCommands directory of Immunity Debugger. We will be using Immunity Debugger. Okay, so here if you want to see that, I just downloaded it already. So I'm just going back to the Immunity Debugger folder, and there will be a PyCommands directory, and you can see the Mona is here, right? So you can just copy it over here, and the first thing you have to do is to configure the working folder. So why we are configuring the working folder is because if we didn't set this thing, all the logs and files created by Mona will be inside the Immunity Debugger directory. So there is high chance that something that is needed will get overwritten and all. So it is better to provide a separate working folder for Mona. So we can do that now. Let's go back to our debugger and issue the command !Mona space config. So this is a command for setting the working folder, space -set working folder. Okay, and then give a space and give the path. So in my case it will be C Mona, and after that you can set the working folder and then the directory here. You can provide the directory. So it can be %p or %i. %p means the directory will be made based on the process name. If it is %i, that means the directory will be made based on the process ID. And you should not add any quotes here. Okay, so that will make some trouble, so don't do that. So it will be Mona/%p. Let the directory be created based on the process name. Okay, once I press enter, it will get executed, and you can see the result here. Return value to the configuration file. New value of parameter working folder is C Mona %p, right? Okay, now you just done the initial configuration. So I told you before there are some global options. So these are some of the global options which you can apply as the filters, right? So -n means skip the modules that start with a null byte. -o means skip OS modules. -p space nr will stop search after the nr pointers. And -m means limit the search by one or more modules. So you can specify it like -m space the module name, and you can if more than one module is there, you can just use comma separated values. And -cm is to limit the search by a module's property. Okay, and the properties are like ASLR, OS, SafeSCH, Rebase, NX, etc. So we will come into this just in a moment. Okay, and -cp is to limit the search by pointer properties. Like if you want the PPRs or call dword, that are Unicode compatible. You can specify it like -CP Unicode. Here actually the SEH will get you all the PPR or the call devote instructions. Okay, and some of the other options are like Unicode, ASCII, ASCII print, upper, num, lower num, numeric, etc. And -CPB is to limit the search by bytes in pointer. Okay, so this is a good feature which can be used for filtering the bad characters. So say suppose if you want a pointer that doesn't have something like 00, the null, then you can issue the command like exclamation mona space SEH, that is for getting the PPR space hyphen CPB. So there is a hyphen there, so hyphen CPB, and then you can specify that particular byte or the combination of byte. So in our case, if you want a pointer that doesn't have null, then you can provide it like quotes /x00 close the quotes, right? So these are the global options, and we will come into this when we are doing with the commands. Okay, now let's go through the Mona commands. We will be going through some of the important commands only. Okay, and the exclamation Mona space PC space styles. This is basically something similar to pattern create in Metasploit. It's used to create a cyclic pattern. Okay, so let's create a cyclic pattern. Let me load. No need. So better. Let me load an executable. You can just do it without an executable too, but I'm just doing it because I want it in a folder related to that executable. Okay, so here you can give the command PC and 5000. This will create a cyclic pattern of 5000 bytes. Okay, so just press enter and you can see that this file it's created. There's a file called parent.txt created in our log folder. So if you just go to our log folder, there will be Mona. So inside that there is a audio coder folder and there is a text called pattern. So you can see that there's a pattern of 5000 bytes, right? So it's created there. So it's without Metasploit you can create the pattern with this Mona itself. Okay, so let me close it. Coming back to the presentation, here there is one command called exclamation Mona space PO space a 4-byte pattern. So this will locate the given 4 bytes in the cyclic pattern. So this is much similar to the pattern offset in Metasploit. Okay, let's take a demo. So finding the offset, first you have to get this pattern into the buffer, right? So what I can do is basically I can just paste the pattern into a fuzzing script, right? So I'm just copying this pattern and there is a file called botfuzz.py. Let me open it in. Okay, now I'm just giving here this pattern and saving it and running it. So it will create a file called play.m3u and I'm just running the application in the debugger. On the file, there is an exception, pause the exception and run. So you can use shift plus F9. Okay, now there is a file play.m3u. Okay, I'm just opening it and it's not crashing. Why? Because it requires a header. So we had seen the buffer overflow exploitation of audio coder previously. So what I can do is basically I can add a header here, right? So I'll be adding HTTP. This is a required header. Saving it and compiling it, running it. So now I can just delete it and power the file, gameplay. So this time the application got crashed, right? So if you just go and view the SCH chain, and if you just follow the addressing stack, you can see that the NSCH and SC handler is overwritten. So this time if you want to find out at what offset this pattern starts, initially with pattern offset we have to provide a value or a 4-byte instruction to which we want to locate in the cyclic code, right? So I'm just using the command PO. It's short for pattern underscore offset. You can use PO. Okay, PO space. It will be AZ5A. That is a pointer to next SH, right? So once I execute that, you can see that the pattern AZ5A found in the cyclic pattern at position 765. So if you just check into a previous exploit that we built for this one, you can see that the junk offset should be up to 765. Okay, now coming back to the presentation, there is one more command called exclamation Mona space find MSP. So that is what it does is it will find the registers overwritten with the pattern, and it can find the registers that point into a pattern. Also it can find the pointers on the stack that points into a pattern. Then it will show all the location of the cyclic pattern, and it can show the pattern size as well. Okay, so let's take a demo of that. So if you just issue the command find MSP, so takes a bit, and you can see that there is some entries in the log, and if you just look here, you can see that the cyclic pattern, the length is there, and then it's examining the registers and where the offsets, and it's examining the registers, then examining the SCH chain, and if you see here, you can see the offset that is just required, at what point the offset there's a junk values we can fill, right? And after that, how much amount of bytes we have, that means you can understand the buffer size, so that we can take care of our shell code size and all, right? So there is a lot of entries like that. So this one gives plenty of information here. Okay, let's go back to our presentation. We have a command exclamation Mona space mod that will list all the loaded modules along with their properties. Okay, you know that in Immunity Debugger, if you just go in the view menu and select the executable modules, it will list all the executable modules, right? Okay, so it will show all the executable modules that comes up or loaded during the process. And in Mona, you can use the command exclamation Mona space modules or just mod. So that will list all the modules that are loaded, right? So we just see that along with the properties, and if you just scroll up a bit, you can see that the base address, the top address, then the size, then the rebase is true or false, the safe SH is true or false, the ASLR is enabled or not, NX compact or not, and whether it is a OSDLL or not, and other descriptions of the TLS or the executables that are loaded, right? Now let's go back to the presentation, and now we have a command exclamation Mona space byte array. So basically this command is used to generate the bytes from 0 to FF. So why we need this is basically to find out the byte characters in the exploit. What we usually do is we will create a pattern from 00 to FF, which contains all the set of characters in between them. So we will try to add this into the buffer, and we will check whether there is any abnormalities with any character. Okay, if there is any abnormality, then that means that act as a byte character. Okay, so you can create the bytes from 00 to FF using this command. So if I just go back to Mona and issue the command byte array, just scroll down and you can see that there is a text called bytearray.text. It's better not to copy from here because there may be some troubles like truncation, and also just better go to a log folder and copy it from there. So there will be the file bytearray.text, and it contains the bytes starting from 00 to FF. Okay, so you can just copy this and paste it into the exploit file, and you can run it, and you can analyze it in debugger and make sure that which one is a bad character and which one is not. There is one more option, that's a filter, kind of filter for byte array. It will be exclamation mona space byte array space -b and then a list of bytes. So what it does is that it will generate the bytes from 00 to FF, excluding that list of bytes. Say suppose if you find out that some character is a bad character, and the next time you want to create a set of say the same set of instruction from 00 to FF, excluding that, then you can use this command. So if you just come back to the debugger, you can see that you can just add the command byte array -b, then specify the list of bytes. We don't want /x00 /x 0a, we don't want /x0d /x /ff. And once you execute this one, you can see that there is no 00, and the 00a's and 0d's are eliminated, and also the FF is also eliminated. So this is how you can use byte array with -b option. Okay, so coming back to our presentation, there is an instruction exclamation mona space jump. So basically this instruction is used to find out the pointers that jumps to a given register. So when we deal with EIP based overrides, what we look for is like jump BSP and all. So you can just do that. And if I come back to the debugger and issue the command, again issue jump space -r. It's used to specify a register that give ESP. So there is a lot of jump BSP instruction. It takes a bit. Okay, and once it is done, you can just go and check the logs. The shortcut is Alt+L. So if you just look here, there is a total of 24 pointers. So you will get all the address here, and also you will get the like the properties like rebase, safe SSH enabled, and other details also. Okay, so let's come back to the presentation. Now we have the command exclamation mona space no ASLR. Basically it shows the modules that are not ASLR or rebased. It's just a simple command, you don't want a demo on that. And similarly there is exclamation no safe SSH. It will list out the modules that are not safe SSH protected. Okay. And there is exclamation mona space SSH. It will list out all the pointers to PPR or called dword. Let's do that. So just simple command, just give the command and it will do the rest. If you just give exclamation mona space SCH, it will search for all the possible PPR instructions or similar call dword instruction. If you just go and view the log, you can see that there's a lot of instructions here. There's almost about 860 pointers, and only the first 20 is shown here. The remaining will be in the text file. So if you just go and look into the file that is SEH, you can see plenty of information over here. So you can have a good idea about all the PPR sequence or similar call dword sequence. There is no, some call dword sequence is also there. So you will get all the PPRs. Also you can apply the filter here, right? Let's say we need the SGH PPR instruction for Unicode. So that is Unicode compatible, Unicode. So just give -CP, that's a global filter, and Unicode, and that will get you the Unicode compatible addresses, right? So just go and view the logs, and you can say there's only one pointer. So this is only the one Unicode compatible pointer. Let's come back to the presentation. Now there's a command exclamation mona space egg, and that is used to create egg hunter code, and you can use the -t option, and then you can provide the tag. Okay, that's a tag for the egg hunter. So if you just Come back to the debugger.